In this video, we are going to learn about Quicksort. It is also known as partition exchange sort. It was given by Moore in 1959 and it is based on divide and conquer technique. In this sort, we pick an element from the list and rearrange the list such that this element comes at its proper place. We call this element as pivot. Now this pivot is at its proper place if all the elements to the left of pivot are less than or equal to the pivot and all elements to the right of pivot are greater than or equal to the pivot. So these equal elements can go either way. Suppose this is the list that is to be sorted and we take first element as the pivot. So after rearranging the list, it becomes this. This 5 has come at its final position and all the elements to the left of 5 are less than 5 and all the elements to the right of 5 are greater than 5. Now this list is divided into two sublists, one to the left of 5 and one to the right of 5. And the same process is applied to these two sublists. For this sublist, 3 is chosen as a pivot and it is placed at its proper position in this list, and then again it is divided into two sublists. Similarly, pivot is chosen for this sublist also. And this process is repeated for all sublists that contain two or more elements. Now let's see the whole process of quicksort. This is the array A that we have to sort. The lower bound is low and the upper bound is up. First we take the first element of this list as pivot. So A low is taken as a pivot. Now the list is rearranged so that pivot comes at its proper place. Suppose P is the proper place for pivot. So after placing the pivot, the situation is this. Pivot has come at its proper place. And all the elements to the left of pivot are less than or equal to the pivot. And all the elements to the right of pivot are greater than or equal to the pivot. And now this is divided into two sublists. For this left sublist, the lower bound is low and upper bound will be P minus 1. And for this right sublist, lower bound will be P plus 1 and upper bound is up only. This process of placing the pivot at proper position is called as partitioning process and we'll discuss it afterwards. Now these two sublists are sorted recursively. First, this left sublist is sorted using quicksort recursively and then right sublist is sorted using quicksort recursively. And the terminating condition for recursion is when the sublist formed contains only one element or no element. And the sublist will contain one element when lower bound is equal to upper bound and it will contain no element when lower bound is greater than upper bound. So now let's take an example and understand this procedure. This is an array of 12 elements and we'll sort it in ascending order using quicksort. Here we'll focus only on the recursion procedure. The process of placing the pivot is discussed in the next lecture. Now initially we have to sort this whole list. So low is 0 and up is 11. And this A low is taken as a pivot. The list is rearranged such that this 50 comes at its proper place. After this is divided into two sublists. For this sublist, low is 0 and up will be equal to P minus 1. So up will be 3. For this sublist, up will remain same and low will be equal to P plus 1. So low will be 5 for this list. Now first we'll sort this sublist using quicksort. So this element is taken as a pivot and placed at its proper place. Now for left sublist, low is 0 and up will be P minus 1. So up will be 1. For the right sublist, up is 3 and low will be P plus 1. So low will be 3. So for this sublist, we can see low and up are same. So there's only one element in the sublist. So we don't have to do anything here. For this left sublist, 20 is chosen as a pivot, placed at its proper position. Now for the left sublist, low is 0, up will be P minus 1. So up will be 0. And for the right sublist, up is 1 and low will be P plus 1. So low will be 2. Now we can see for the right sublist, low is greater than up. So there is no element in the right sublist. For the left sublist, low and up are same. So there is only one element. So we don't have to do anything. It is at its proper place. Now this left sublist has been sorted. Now we come to this right sublist. Now for this sublist, low is 5 and up is 11. So 83 is the pivot and it is placed at proper position. Now for left sublist, low is 5 and up will be p minus 1. So up is 8. For this sublist, up is 11 and low will be p plus 1. So low is 10. First we take this sublist. 60 is the pivot. It's placed at proper position. Now for left sublist, up will be p minus 1. So up is 4 and low is 5. And for right sublist, up is 8 and low will be p plus 1. So low will be 6. We can see for this left sublist, low is greater than up. So there is no left sublist. Now we take this right sublist. Here 74 is the pivot. It is placed at proper position. Now for left sublist, low is 6, up is 7. For right sublist, up is 8 and low will be p plus 1. So low will be 9. So we can see that for right sublist, low is greater than up and so there is no element in the right sublist. For this left sublist, 71 will be the pivot. Now for the left sublist, low is 6 and up is 6 and for right sublist, low is 8 and up is 7. So there is no element in the right sublist. For left sublist, low is equal to up. So there is only one element and there is nothing to be done. We come to this list. 89 will be the pivot. Now for left sublist, low is 10, up will be 10. And for right sublist, up is 11, low will be p plus 1. So low will be 12. There is no element in the right sublist and there is only one element in the left sublist. So there is nothing to be done. And after this process, the whole list becomes sorted.